This is Concept B, where we're going to be focusing on the classification of matter, specifically substances, mixtures, breaking those down into elements, compounds, and then the various types of mixtures. So by the end of this video, you should have a basic understanding of identifying and classifying types of matter. You should also be able to recognize various techniques that can be used to separate matter either chemically or physically. So chemistry is the study of matter and the changes that matter undergoes, and also the energy associated with those changes, which is what this unit is focused on. Matter is the physical material, and we've talked about this before, that has a definite mass and occupies a definite volume, so it has density. And we also should be aware that matter cannot be created or destroyed. Now, how do we classify this? Well, it's classified very similar to some of the classification systems you learned about in biology, and it's divided into groups, though, based on the kind of particles, how the particles or atoms are arranged, and then the characteristics of the materials. So this is focused on, again, types of matter, unlike some of the topics that you looked at in biology. But same type of idea, how we're going to break them down. They're going to have similarities, how we separate them by their differences. So our first thing are called substances. This is one of the big general categories. It can be referred to as a pure substance, but you should be able to recognize it just by the term substance. So kind of how we use that on an everyday basis has to be adjusted. Now, substances are very specific in chemistry. These contain the same composition of a material throughout the sample. So each piece of a substance has to have the same chemical makeup as the rest of the substance. These cannot be separated by any type of physical means, and all substances have to have a chemical formula. So the two types of substances. The first one is an element. This is the simplest form of matter. The entire sample is made up of one type of atom. Atoms are the smallest unit of an element, so all of them only have one type of atom in them. Element symbols are either one letter, which is capitalized, or two letters, with the first capitalized and the second lowercase. So when you're in class, or if you have your reference table right now, look at the periodic table, you'll be able to observe this. Symbols are all listed on the periodic table. So here's some examples. We have carbon, neon, potassium, cobalt, oxygen, and sodium. And as you can see, single letters are just simply capitalized. Ones that have two letters have a capital and then a lowercase letter following it. The big thing with an element is that it cannot be broken down by chemical changes or, as we said before, physical changes because they're made up of the one type of atom. Here are some examples. I have sulfur and iodine. This is we're going to talk more about tomorrow, which is a particle diagram. So if I were able to actually zoom in and look at the atoms, I'd see all the same type of sulfur atom. Or for iodine, you're going to see something called a diatomic element, where we have two of the same atom bonded together. But again, it falls under the correct definition of an element in which all the atoms in the sample are of the same type, which holds true even for diatomic elements. So the other type of substance is a compound. This is a substance that is made up of atoms from two or more elements that are chemically bonded together, and these always are in a fixed ratio. So many of you know that water's formula is H2O. So this is a compound. You have to have two hydrogens bonded to exactly one oxygen in order to have water. So that's where this fixed ratio comes from. Compounds have to have also a chemical formula, but there has to be at least two or more chemical symbols present. So in these examples, you can see that you have Na and Cl, H and S. In this case, it looks very similar to cobalt from an element, but you can see two capital letters. So we have carbon monoxide and so on. So again, you have to be able to identify at least two or more chemical symbols for it to be a compound. So like I just said, we had water. Here's a little particle diagram that we'll talk about more. They all match each other, which also makes it a substance. You don't see any other type of particle besides water in it. If I look at sodium chloride or salt, you can see that again, I have my compound here of two or more elements bonded together, and then the rest of the sample matches it. So you can see that I have pure substances here where only that one type of particle is present. Now, compounds, these can be changed by chemical means, not by physical, but by chemical means. So some examples of this would be something like combustion, we have electrolysis, cracking, smelting. These are all examples that we'll talk more about in class tomorrow that can actually break compounds apart. All right, so we talked about substances, which include elements and compounds, and now the other broad category are mixtures. These are composed of two or more distinct substances, so separate types of substances, and these are combinations of substances that are not chemically combined together. Due to this, mixtures can be separated or broken apart by physical means, and unlike substances, their compositions can be varied from one sample to another, especially compared to compounds. This is their big difference. So there's two types. We have a homogeneous or homogeneous mixture, which we also can refer to as a solution. The two or more distinct substances are uniformly dispersed, so this looks the same throughout. All the parts of the sample look the same. There are various types of solutions. The first one that I think you should be very aware of and either highlight or star in your notes is called an aqueous solution. These can't be separated by filtering due to their small particle size, and aqueous solutions look the same throughout. They also appear transparent, meaning you could see through them. And salt water is a great example of an aqueous solution. So here again, looking at a particle diagram, which we'll talk more about tomorrow, is water and sodium chloride. Here we have the two separate compounds, and they're mixed together, being evenly dispersed amongst one another. So this makes it very different than a substance, which only could have one type of particle. Here we have two distinctly separate types of particles mixed together. And there they are. Okay, another type of homogeneous or homogeneous mixture is called an alloy. This is a mixture of metals that are not chemically combined with each other, but they're mixed together to enhance their properties. Two big examples or common examples would be steel, which is a mix of iron and carbon, or also bronze is a very common example, mix of tin and copper. These elements are not bonded together, they're simply a mixture in this alloy. And then our other type of mixture is a heterogeneous mixture. This is two or more distinct substances that are not uniformly dispersed. Basically, the particles are too large enough to form that homogeneous or homogeneous mixture, so we're able to see the different substances within it. The composition varies from one region of the sample to another. So here are some various examples you can see in the particle diagram. They're clumped together, which means with our eyes, we would see the different pieces within the mixture. So whether it's an everyday sample of M&Ms would be a everyday type of example, but we can also look at some other ones where you can see the different particulates in it, meaning that we have a heterogeneous mixture. So some physical separation techniques, this is important. We'll be doing these in class throughout a couple of labs. Filtration is a process which we can separate a solid from a mixture. This is a great way for separating heterogeneous mixtures due to their larger particle size that the filter can trap. We can also use evaporation. And evaporation is when we have a liquid that evaporates into a gas. This is a great way to separate something like a homogeneous mixture, homogeneous mixture, such as salt and water by heating it. We're able to drive the water out and leave the salt remaining. We also have distillation. A key word for distillation or phrase is boiling point. This is a separation just solely based on boiling point. It's often a way to separate two liquids that have different boiling points. So we heat it up, we evaporate out the first liquid that has the lower boiling point and separate it, and then we're left with the liquid with the higher boiling point that remained. So whenever you see a question about separating a mixture based on boiling point, you're looking for distillation. And then finally, chromatography. You actually did this in biology, many of you, in a lab where you looked at the pigments in a leaf. You'd perform chromatography. This is a way to separate a mixture based on differences in solubility and a couple other factors that we'll talk about in class. Okay, so this is just some practice. You might want to pause it, go through all the questions, and then come back and check. So here you had to circle elements, box, compounds, and really you should have been looking at chemical symbols to do so. We have the first one circled, the next two with a box because they're compounds, and then the last two with circles because they're elements. So in the above example, which species circled above, how many different symbols are listed? Well, for all the ones circled, because they're elements, they all have one symbol present. For the compounds, they're going to have more than one. So in our first compound, we have 3, H, S, and O. The second one, we have 2. And then the last ones, which are elements, only have one chemical symbol listed. Even the diatomic element, while there's 2, those symbols would be the same. What is the minimum number? How many different symbols are listed above for the ones that are circled? That would be 1. So all the elements have 1 listed. What's the minimum number of symbols that must be present in order for a species to be considered a compound? At least 2. Alright, so here are some separation techniques. This one was looking at how you have sand that has been stirred into water but yet settles in the bottom. What type of solution is this? It would be a heterogeneous solution, which means you would want to use filtration to separate it. Now for number 5, we have a mixture of two liquids, water and ethanol. So what type of solution is this, and then how would the students separate the two liquids? Well, the type of solution is going to be a homogeneous mixture, and we want to use distillation to separate out the two liquids based on their boiling points. Okay, so that was a very quick review. You are all set with Concept B. Come ready to class tomorrow honors. You should be moving right along to Concept C.